We have with us Dr. Mark Easter. He is a Senior Research Associate at the Natural Resource Ecology Laboratory at Colorado State University. He works there as an ecologist and modeler, and he is the project lead for the COMET-Farm tool. And he will be talking to us today about resources for estimating and maintaining carbon using COMET. So take it away, Mark.
All right. Well, thank you, Dan. Hello, everybody. It's great to see a bunch of folks on the list there. Folks that I've worked with before, and some new names to me, and I look forward to the opportunity to meet you all. So it's really great to have the opportunity to present to you all, and also I appreciate following John Lee's presentation. I feel like he set the stage for an awful lot about what I want to talk about, and so I felt like he did a really good job. I appreciated what he had to say there. So I'm going to be giving you an introduction to the COMET-Farm and the COMET-Planner tools, so I guess I'll jump in here. Dan, I'm not able to, there we go. Now I can advance the slides here. Let's see, it is, there we go. Okay. I first want to acknowledge my colleagues here at CSU. Keith Poshton is our team leader, and then we have a host of other team members here supporting this work. Really want to hold up our partners at the NRCS. Adam Chambers is the project manager and our main contact at NRCS on this project. They've been real strong supporters for this work for over 15 years, and we're delighted to be able to work with them. Likewise with folks at the Office of the Chief Economist, the Climate Change Program Office, where Marcy Baranski is currently our contact there. And then folks at the Agriculture and Research Service. Marlon Eve has been our contact previously at the Climate Change Program Office, but now he's moved over to the ARS, and we're delighted to be able to continue to work with him. Also Kerry Steenworth at the ARS office in Davis, and Steve Del Grosso at ARS here in Fort Collins. I'm going to be talking about the COMET-Farm tools and COMET-Planner tool. You can see the URL here at the lower left for COMET-Farm and at the lower right for COMET-Planner. The COMET-Farm tool is currently being, we've got some maintenance work going on it right now, so we've disabled the functionality on the tool. We expect to have that up later today. Dan, I'm having trouble, oh, there we go. Okay, so here's the outline for this presentation. I'll be giving you a brief introduction to the tools, be talking about some details for the tool enhancements for 2016. Then I'm going to give you just a brief rundown on mitigation analysis in croplands, agroforestry, forestry, and also in animal agriculture and livestock. And then open things up to discussion, and just want to invite you all in to work with us to help us improve the tools. So we'll start off with a brief introduction to the COMET tools. So this slide is intended to provide you some context for why this work is important, why we need to be able to provide assessment tools for users to be able to assess what their the contributions of their activity in agriculture may have towards issues with climate change. On the right-hand side here, you see this this pie chart. It shows that agriculture contributes about 8% of the total U.S. greenhouse gas budget, and this is from the U.S. EPA. This is from the 2013 inventory, which is the most recent information we have at the current time. Now, these are direct emissions right here. If we added up the other indirect emissions associated with electricity use contributing to agriculture, transporting crops from the field or from livestock feeding operations to processing facilities, industrial contributions for manufacturing of farm inputs, implements, chemicals, and that sort of thing. If you added it up, it would be quite a bit larger. And current estimates are it's somewhere between 20 and 30% of the total U.S. greenhouse gas emissions are associated in some way with agricultural production and food processing. But what we're talking about here, what the COMET tools are really designed to provide an assessment around, is the direct emissions from the farm, from the livestock herd, from an agroforestry woodlot, or from a forestry plot. The principal gases associated with this are carbon dioxide, methane, and nitrous oxide. And we'll be talking about those coming up here. So, there we go. So this slide here was prepared by my colleague Amy Swan. This was introduced into the 2007 IPCC assessment. And what it's really intended to show is that there's a broad variety of greenhouse gases that are associated with agricultural production. We have nitrous oxide associated with application of fertilizer and also with manure from livestock. We have methane coming off of livestock, methane, nitrous oxide, NOx, and CO2 associated with burning agricultural residues, and methane coming from rice production. But at the same time, we also have a lot of carbon being cycled through agricultural systems through CO2 uptake from photosynthesis, soil carbon cycling associated with decomposition of plant residues, but then also CO2 being given off from soil when soil is tilled, as John Lee so aptly explained in his previous presentation. What we've learned in our work and the work of many others is that we need to take a whole systems approach when we look at agricultural greenhouse gas mitigation, because some activities that can actually reduce greenhouse gas emissions in one aspect or reduce emissions from one particular gas can actually increase emissions from another. An example might be increasing nitrogen fertilizer applications to try and increase plant growth so that you have greater residues available for carbon sequestration. What we find is that the nitrous oxide emissions from that sort of activity can actually overwhelm any carbon sequestration benefit we might get from that activity. And so we have a net increase in greenhouse gas emissions. So it's important to take, just from this example, and there's many other examples, it's important to take a whole systems approach to your farming enterprise in order to assess what your emissions would be. And here's really why this is important. Every 1% increase in soil organic matter on a 160-acre field with the silt-loam soil would equal about 900 metric tons of carbon dioxide equivalents in carbon sequestration. And this is equal to emissions from 190 passenger vehicles for 1 year. So I'm going to be talking about the COMET-Farm and the COMET-Planner tools. These are web-based greenhouse gas inventory tools for land use, and they're designed for conservation scenario analysis. The COMET-Planner tool is a 3-click tool. It's designed to provide users the opportunity to assess at the top level what the potential greenhouse gas benefit of a single conservation practice would be. These are tied to NRCS conservation planning standards. And then also the COMET-Farm tool, which is designed to provide a more in-depth assessment at the individual farm and field level of what the whole system benefit of a suite of practices would be. The methods that are embodied behind the tools are really described in this document right here. This was published in July 2014. Marlon Eve led the effort when he was at the Climate Change Program Office. If you Google on this term, quantifying greenhouse gas fluxes, or the title here, Google on the title, you'll be able to go immediately to the site where you can download this document. It was peer-reviewed, it's been sanctioned by the USDA, and it's intended to provide whole system greenhouse gas emissions estimates at the entity level. And so that would be an individual livestock herd or an individual parcel, an individual agroforestry windbreak, for example, or a farm woodlot or a forestry plot. Now I'm going to try to describe the difference between COMET-Farm and COMET-Planner. And in this slide right here, it shows some of the different pieces of the COMET-Farm tool. In the upper left-hand corner, show here where users can provide information about the specific location where their enterprise is located, and also describe their management activities very specifically about what happens on that parcel or with that livestock herd. This information is used in combination with details on historic cropping rotations derived from the NRI and from other sources, along with a climate database, the North American Regional Reanalysis, and then the SERGO from the Web Soil Survey soils database. This, combined with a number of different empirical methods and also driving the DayCent model, generates outputs which are then returned as results in the COMET-Farm tool. Now I want to ask you to just look in the upper left-hand corner here as I go to the next slide here, and I'll show you what the key differences are between COMET-Farm and COMET-Planner. COMET-Planner, rather than a very specific location, derives information that's averaged across a generalized region. And it's tied to very specific conservation practices that are averaged, again, across that region, using a lot of the same methods, not all of the same methods, but a lot of the same methods to provide an average mitigation effect for a single conservation practice. And this next slide tries to explain that a little bit more. On the bottom here, we show COMET-Planner. What it's intended to do is allow a user to assess a business as usual scenario against a conservation practice to show what an individual practice benefit would be. This is averaged at a multi-state level, whereas COMET-Farm is intended to allow users to assess against, again, a baseline scenario, business as usual, but against a single or multiple conservation practices that are added in total and allows the user to compare the greenhouse gas benefits on the same balance sheet. So I'm going to give you just a brief rundown on improvements to the COMET tools that are in the works right now. In COMET-Farm, we're adding specialty crops from some work we're doing in California in a partnership with the California Department of Food and Agriculture. And I think a lot of the improvements we're making there will actually will improve the capabilities for users in the Southeast region. And I'll get into the details in that in a minute. We're also adding a number of rapid data entry features. We're adding an API service so that users from other tools can allow model runs through the COMET-Farm system and the COMET-Planner system. We're fully integrating livestock grazing into pasture, rangeland, and cropland systems. We're continuing to do some work on improving how the model responds to organic matter additions and expanding our outreach efforts. We're also planning this coming summer to release the COMET tools into an open source environment and doing some work to improve reports, adding maps and a flexible baseline year for when conservation practices are implemented, and then a forestry module. In COMET-Planner, we're doing some work to try to link the COMET-Planner to the COMET-Farm tool via a meta-analysis, and that work we're preparing to implement that work shortly here. We're also trying to improve the spatial resolution in COMET-Planner and make improvements based on lessons learned from the specialty crop work. So I'll give you a rundown on the work we're intending to do with the specialty crops. So this is an effort that involves the NRCS, Adam Chambers, and also folks, Tom Hett and others from the California State Office staff, along with folks here at CSU. We're working closely with Amrith Gunasakara at the California Department of Food and Ag in Sacramento, Kerry Steenworth at the Davis office of the ARS, Marcy Baranski, Climate Change Program Office at USDA, and then Will Horwath and Martin Berger at UC Davis. And this is where I think the nexus is to folks there in the southeast region. A lot of these crops are specialty crops in California, but they are also grown in parts of the southeast. We don't currently have the capability to grow these crops in the COMET-Farm tool, but we're going to be adding these over the course of the coming year. Processing tomatoes actually is in the tool right now, but we've identified some ways that we can improve how we model tomatoes in the model. The rest of these crops are not currently in the tool. Based on what we learned from the process of parameterizing these crops to run in DayCent and to work in the tool, we'll also be using to improve the graphical user interface in COMET-Farm, and also make improvements to COMET-Planner based on this. We're also working on adding a rapid data entry feature into COMET-Farm. The idea here is that somebody can use a drag and drop approach where they essentially can select a single crop from a list of icons here, drag those over into a cropping sequence, and then assemble a crop rotation rapidly. And this would be based on average or generalized cropping practices at the MLRA level. This will include planting dates, harvest dates, fertilizer use, and also tillage practices. We also intend to add in a feature that allows users to add or impose upon their cropping practices regionally important conservation practices, so that users can select from a list of conservation practices, and those practices will be automatically imposed on whatever their baseline, whatever their business as usual is. And this will include improved nutrient management, adding cover crops or cropping intensification, reducing tillage, adding agroforestry systems such as windbreaks and riparian buffers. Also integrating livestock grazing systems or changing livestock grazing to improve grazing management regimes. And then other carbon-intensive management and trace gas reduction strategies that might be regionally appropriate. And I'd just like to make a call to all of you that if it would be interesting to hear from you what your regionally important conservation practices are, so that we can make sure that we accommodate those in the Southeast region. We're also preparing an API, and the idea behind this is to allow for users or people who are managing different tools, different sorts of land management tools that are out there, to be able to make COMET-Farm process requests, essentially run models through the COMET-Farm system, and then show the results in their own system. This will be free and open to basically anybody who wants to do this sort of thing. We've just completed some work in the COMET-Farm tool. Whoops. I'm going to back this up. There we go. We've just completed some work, and it's live on the tool right now, to allow users to integrate livestock grazing into COMET-Farm. The idea here is that people can either graze livestock on a pasture on rangeland, or they can add livestock integrated into a cropping system. And a couple of examples that come into mind are, you might have a grass hay system where you might bring livestock in the fall and let them winter on the hayland with supplemental feed. Livestock might be brought in for a week or two under a winter wheat system in the spring. The idea here is that these grazing practices are added in on the same page in COMET-Farm, where users describe what their crops are, when their planting date is, and when their harvests are accomplished. We're also expanding our outreach efforts. Last year we were focusing on California. We're expanding our outreach into the entire lower 48 state region. We've built a number of webinars that are available on YouTube. We also have a number of paper tutorials for each of the different modules within COMET-Farm. We have streaming videos users can watch. We have a help desk that we staff 7 days a week. We also have ad hoc on-request training sessions. So if users from your region wanted to have a specialized training for specific practices or for a specialized group within your region, just contact us. Contact me. I'd be happy to arrange that for you. We're planning to release the COMET tools into the open source environment this summer. This is intended to provide maximum transparency so that users can have a direct eye into how we implemented the methods document. We're also hoping to improve collaboration opportunities with the greenhouse gas registries, with other governmental agencies, with NGOs, and extend our work to others beyond this group. What we're going to be releasing will be the calculation modules, the cropland, livestock, and forestry graphical user interfaces, the reporting tools, and the database structures. We plan to make some improvements to COMET-Planner in the coming year. We have this aspirational goal of linking COMET-Planner directly to COMET-Farm via meta-model, meta-analysis, so that they're fully aligned and that we fully implement the USDA methods document behind COMET-Planner, and also to improve the spatial resolution. It's currently, the results that are provided through COMET-Planner are a multi-state level. We'd like to make that at either the state level or the MLRA level, so that it provides a more regionally specific result for the conservation practices described in that tool. Also plan to include improvements based on our lessons learned from the specialty crop work and make available an API web service so that anybody else from outside could actually make model runs through COMET-Planner without having to go directly through the tool, and then again release it into the open source environment with COMET-Farm. So I'm going to spend the next few minutes just running through some examples of conservation scenario analysis. And this is specific to COMET-Farm. And I'll start off with describing the cropland demonstration project that we have in the tool. Now, for anybody who is currently registered or would like to register and use the tool, the very first page that you get to is what we call the activities page, and allows you to set up specific practices or specific projects related to, maybe there's a grower that you're working with, or maybe you have an agricultural experiment that you're interested in, where you want to assess what the potential greenhouse gas benefit of the conservation practices in that experiment or that grower may be implementing. So on that page, you can access what we call our demonstration projects. So in each of the 4 modules within COMET-Farm, which are croplands, agroforestry, forestry, and animal agriculture, we have a separate demonstration project. You can select that demonstration project, and the tool will automatically build that project for you. So you can go through and assess with that project, and also using our tutorials, you can assess how to use the tool. The example we have for croplands is from the ALEE demonstration farm operated by Iowa State University. It's in the Des Moines Lobe in northwestern Iowa. And in this demonstration, we have a 62-acre field where we've implemented a conversion from intensive tillage to no tillage. In the reports, what it shows is that we have a potential conservation benefit of about 38 metric tons of carbon sequestration resulting from that. I advanced that a little bit too quickly, sorry about that. And so the main benefit there is from carbon sequestration. There's also a small net reduction in nitrous oxide emissions associated with the change in practice. The user can also implement an agroforestry demonstration project. The example that we've implemented here is from Mendocino County, California. What we set up the example to do is to add 2 different types of riparian buffers to a lowland soil in the southern part of the county. They total 10 acres in size. What the implementation of these benefits shows is that on that 10 acres, over the first 50 years of the practice, after being implemented, that there would be an average yearly benefit of about 16 metric tons of carbon dioxide equivalents. You can see in the report here, it shows what the sequestration rates are from the different tree species that were added in this riparian buffer. We also have a forestry demonstration project. This was implemented as an example from the University of Idaho Experimental Forest. This is in the foothills of the Sawtooth Range. In the example that we have here, the user, we have 3 different parcels that were added to the experimental forest, and each of those parcels we implemented a different type of management practice. Now the forestry models that are run behind this are tied to the USDA Forest Service FVS model. The tool currently looks up what we call the Green Book values that the Forest Service built in the mid-2000s. This was about 10 years ago. These are show the average greenhouse gas or carbon sequestration in different forest components from dominant forest stand systems throughout the country using a number of what are considered to be the dominant management practices from that region. This is going to be updated in the coming year in a collaboration we have going on with the Forest Service right now. So we'll have new regionally appropriate forest stand systems and also forest management systems that will be available in the tool. We're also implementing a method here so that users will be able to run the FVS model on the fly, essentially behind the tool, so that they can look at individual, or the benefits of individual practices on their own parcels throughout the United States. And then the last example is we have a livestock demonstration project. Now we're going to be changing this. It's currently set up to simulate a conversion from an anaerobic lagoon to use of an anaerobic digester. This is at the Cal Poly demonstration dairy at San Luis Obispo, California. Now we're going to be, unfortunately have had to disable that methane digester, and so we're going to be shifting to another example. So I won't spend a lot of time on this, but the idea here behind this conservation practice was to show what the benefit of adding a anaerobic digester to a livestock system would be. So the COMET tools are evolving. They've gone through a long development process. The process started really in 1999 when our partnership with the NRCS began. We're on our third iteration of the tools right now, and they're constantly changing because of dialogue with users like yourself. New features get added, new capabilities get added. We also like to try to find ways to improve the user experience to make it as quick, set up the tools so people can use it as quickly and as efficiently as possible. So we really want to solicit your help in helping us to improve the tools. We'll ask these questions. Where can we improve the tools to reduce project costs and maximize their relevance? Are there opportunities to expand the user base? Are there user groups that you all know of who would be interested in having some exposure to the tools where we can do an individualized training? And are there gaps, either in the data or in practices, whether that's conservation practices or crop management details or actual crops? Are there critical land use and management innovations that can't currently be assessed through the tool? We'd like to hear about that. And you can reach us via our website. I think you all can get my email address from Dan, or if you want to reach me, you can reach me at mark.easter@colostate.edu. That's mark with a K, .easter, like the holiday, at colostate.edu. And so I'll actually back this up to this slide here. I'll go ahead and end at that point.